What's going on, my folks and my peeps and all of that kind of stuff? Just kind of wanted to let you know, yeah, I'm a little sick. We're going to get through a lot of stuff today. We probably won't finish the entire lecture, and that's fine. I have it allocated for today and Thursday, so we're good. It's a two lecture kind of day, and we're going to talk about some stuff. Class will start in about 5 minutes, but I wanted to take some 5 minutes to maybe talk to you guys about, like, let's see. Who do we got here? We got Jenna, Jordan, Nicholas, and we got people logging in. So while we're hanging out, I wanted to kind of take that five minutes and kind of show you around the class and what I changed up. One of the things you guys hammer me on is you guys don't like how I don't put up Dropbox dates, like due dates and whatnot. And I had my reasons for that, but you know what? I've broken down and I said, all right, fine. I will put in due dates for all the assignments, which is actually a really cool thing. So when you click on an assignment, and I think this is a little bit different from how it usually works. When you click on an assignment, you don't usually see this due date, do you? But now I'm putting them all in. So now you'll know when it's due. And not only that, but you'll be able to see like a calendar. And I think this thing exports out to Google Calendar. And so like, what is the 17th? The 17th. I think this thing will actually tell you, okay, this is due at this time. I don't know how this calendar works, but you guys can figure out the calendar. Anyway, we cool with that? So your due dates and all of that kind of stuff is actually going to be in the thing. Oh, here we go. So when you click on the calendar, it tells you, oh, okay, well, here's what's due today. The multiverse quiz and then this Dropbox, and you got to do the reading and the multiple choice quiz, and booyah, there we go. That's all done for you. So we're cool with that? We like that? Good, bad, ugly? What do you think? Yeah, good, bad, meh? Okay, cool. So that should tell you, I mean, I'm still going to use the plan. I'm still going to use the other stuff. But now I'm adding an extra part to it, which says, okay, well, now we're going to also do some of the reading. I'm going to put the Dropboxes up. My computer is really slow today. Come on, computer. Figure it out. All right. Some of you guys were asking about like the stars and galaxies and universe reading, and I took a look at it again, and I couldn't figure out what you guys were having trouble with. So maybe sit and talk with me about that for just a second, because when I looked at it, I was like, this thing looks perfectly fine to me. I don't know about you guys, but to me it looks good. So maybe I don't know. You guys don't like the questions and how the answers weren't there in the reading. And I think that what you guys didn't do is you guys didn't look at all the pages within that document. And the document is still opening up, and hey, I got 3 minutes before class starts, so we're still good. We're just kind of hanging out. We got 5 minutes. All right, there we go. So here's the assignment, and I'm asking you to read the 3 different sections. I only put the first section up there thinking that you'll click to the next one, but this time I changed it up and I put the 3 different sections. So read this. Yes, this was due last week, but since some of you guys complained and said, hey, not all of the answers were there, then my answer to that was, okay, fine, I'm going to make it due next week. Or, well, this week, technically. So I think this one is due this Friday. Even though it was due last week, I changed the due date just to kind of like appease you folks. Cool? I have no idea why it's taking so long to load. But anyway, when you read these contents, you got to go to the next topic and the next topic after that. But I have those things hyperlinked in here So we're good. No, I didn't grade it because I grade things after the due date. So unless something had the due date, I won't grade it. But I know that a lot of you folks turned it in. And it's only like 8 questions, so we're good. We cool? What's the resource for the multiple choice? Let's see, I haven't taken a look at that in a while. Let's go and take a look at that. And then we're going to get started with our class because it's 1 minute till go time. So the multiple choice, here's the assignment. Oh, okay. Yeah, I just made a multiple choice quiz for you guys to take. I don't have like a little like answer key or something that you put in the answers to. So what I want you to do is just like make a Word document or print it out and circle the answers and then scan that into me. What resources do you have? My answer is you can use anything you want. Hopefully what you've learned so far and what you'll learn by Friday, you'll be able to answer all of the questions. But, like if you need to look it up, then go look it up. I'm fine with that. I'm not going to, burn you for looking something up on the internet. Cool? All right. Well, actually, we're going to cover what the Milky Way galaxy is. And so that will be something that we'll talk about today. Cool? Oh, the second one. Well, hey, why don't I get started up on my lecture, and then I'll answer those kinds of questions. So we talked about this thing called the Kuiper Belt. And it rhymes with viper, but it's, spelled Kuiper. And that was kind of the last thing we talked about. I'm going to talk a little bit about some planets, or dwarf planets for that matter. But I'm scrolling out, I'm zooming out, and we got the Kuiper Belt right here. It's bigger than the biggest star, and that's because our sun is about this small, and then the Kuiper Belt is the asteroids that are on the outside of Neptune. Right? We have the asteroid belt, which is between Earth and Mars. No. It's between Mars and Jupiter. But then the Kuiper Belt is even bigger than our solar system, and that's where a lot of those asteroids hang out, right? So we've been talking about asteroids, we're talking about meteoroids and meteorites and all of that kind of stuff. And so I'm going to wrap up this idea about, what's in our solar system. Now we're going to talk about like stars. So I've got 2 stars that I kind of really wanted to highlight, and I like these guys. So we're going to talk about these things called dwarf planets. Now, you don't call people dwarves. I don't think that's very nice to call them, nor do I think that they like being called. They like being called little people. But these are actually called dwarf planets. And one of the most famous dwarf planets, do you guys know what the most famous dwarf planet is? Well, what's the most famous dwarf planet to you? Pluto! Exactly. We love Pluto. I have a question. When you were kids, did they teach you Pluto, or did they say, no, that's not a planet right off the bat? You were kids in like what, you were kids in 2000, huh? Okay, you were taught Pluto? Alright, I was just making sure. So you guys kind of have a small pain in your heart to say, oh, I miss Pluto, I wish it was a planet. Yeah. Yeah, well, Pluto is about this size. Here's our moon, here's Pluto. Pluto is a dwarf planet. And the reason why it's a dwarf planet is because we more recently discovered these different bodies within our solar system. Like this one is called Haumea, or Haumea, and this one is it's like an asteroid-sized thing. It's actually a really big thing, but it's still really small, and its gravity isn't big enough to clear out the solar, or the stuff that's in the area, so we can't call it a planet. Nor did Pluto. Pluto's gravity isn't big enough to clear out like all of the other debris that's next to it. Because usually, if a planet is big enough, it's basically going to attract all of this debris. Pluto didn't do that, so Pluto, I'm sorry you got downgraded, buddy. Yes, Nolan, we were talking about Io. Io is it's the moon. It's the 3rd moon of Jupiter. Jupiter has like 16 of them that are confirmed, and there's like 50 of them that are not unconfirmed. They're just a lot smaller than what we consider moons. But Io is the most volcanically active body in the solar system. That's a pretty cool one too. But I mean, like, look, like, Pluto isn't that much bigger than California. What? Yeah, Pluto isn't that much bigger than California. Like the Great Barrier Reef in Australia is bigger than Pluto. So I'm just saying, like Pluto, I don't feel that bad now that you got downgraded to a dwarf planet because you're a small dude. Our moon is bigger than Pluto. Which kind of makes you think like, wow, that's pretty cool that they discovered it in the first place. Because if it's so small, how did they even see it? And it's so far away? Yeah. Go talk to that astronomer who discovered it. And actually, I think that that's a pretty cool story that I won't get into, so I apologize. Let's keep moving on. We have Haumea, and Haumea is now has two moons. One is called Namaka, and the other one is called Hi'iaka. And are they Hawaiian? Do they sound Hawaiian? And the answer is yes, they are named after the Hawaiian goddess of childbirth. And so you figured that the Haumea, which is the Hawaiian goddess of childbirth, actually birthed two children, which are the two moons. So that's kind of what it is. Why is it Hawaiian? I have no idea. Actually, I feel like maybe possibly it was discovered by the Keck telescopes, which the biggest telescopes in the world, mind you, are actually in Hawaii. And maybe they discovered it, so they get to name it. Hawaiians discovered it, Hawaiians got to name it. Booyah, take that, Western world. Alright, we also have one called Makemake, and I suppose that if you're more like more of the mainland style, this would be called Make, but it's Makemake. And yes, it is also a Hawaiian name. I have no idea what it means. I'm not a Hawaiian expert. Actually, Makemake is not Hawaiian. It is Eastern Island. It's those dudes that have those big, tall statues that have the long face. You guys remember from like Night at the Museum, the guy was like, "Bring me gum, dum, dum." Yeah, I don't know. That's the Eastern Island guys. It was named after one of their gods who created humanity, and that's what the name of this guy was. Pluto, our dearly beloved friend, who was once formerly a planet, and we learned it as planets, but now it's not a planet because it got downgraded. Poor Pluto. And people feel really like up in arms about this. Anyway, Eris is another planet. It's a dwarf planet. It is actually a dwarf planet, so it's actually bigger than Pluto, believe it or not. But it's still a planet. Alright, so now what we're going to do is we're going to talk about comets and stars and all of that kind of stuff. Let's see. Where's a comet? I'm going to zoom out, zoom in. I really want to show you guys like the different sizes of things. Alright, there we go. Halley's Comet. So we talked about a comet. We did talk a little bit about that. And then we're also talking about stars. And the most popular star that you should know of, hopefully, is our sun. And he is a very important one. So we're going to talk about constellations. And here's the thing about constellations. Constellations is like the Greek old school television. Alright? Now, back in the day, they didn't have computers, they didn't have Minecraft, they didn't have the internet. They had the stars to look at. So what did you do at night? No, you did not put on a movie and eat popcorn. You put on your popcorn and then you went outside and looked up at the stars and you kind of like made up stories based off of that. And that was very entertaining for them, and so they actually got really good at doing this. And so they looked up in the sky and they said, hey, this group of stars looks like a hunter. So since we're Greeks, we're going to name that Orion the Hunter, and we're going to talk about a story about some dude who ended up like stealing from like the Greek god Zeus, and so now they're really upset, and then he sent a scorpion after him, and so now we have Orion the Hunter. We cool? Now, here's the thing I wanted to let you guys know, is even though this grouping of stars is all put up together, and this is actually what you would see at night if you went outside at night, although in recent nights it's kind of been very stormy. But what you would actually see is these stars up in the sky, and you would say, oh, that's pretty cool. Do we use that? Do we use, like, the Capricorn and the Aries and, hey, what's your sign and that kind of stuff? Do we use that in science? Like when you read your horoscope, do we use? I figured those are horoscope things. No, no, and actually, yes, we do. We do use them. We don't use horoscopes. Horoscopes, I don't think, are scientific, but we use constellations and these Greek stories and all of this kind of stuff because it helps us identify where things are in the sky. Right? Instead of calling things NGC 2238, hey, did you go outside and see NGC 2238? And then you'll ask, well, where is that? And then they'll say, well, it's right by NGC 2239. Right? And you're just like, where is that? And then I would say, okay, all right, check this out. There's a dude up there that has 3 stars in his belt. 3 stars in his belt means that dude is Orion. Orion's right shoulder is a big star called Betelgeuse. Just to the right of that star is NGC 2238. And then you would be like, oh, okay, now I can look up in the sky and actually figure out what you're talking about. So like, we still do use like Maui's fishhook, which we actually call Scorpio. And we still use Orion and the constellations, but really as a way to identify things. And here's the thing, is even though these stars look close to each other, they're actually not. Like, for example, are my fists close to each other? No. See, like, when you're looking at it like this, they're actually almost touching, see? But then you guys understand that when I turn this way, like my fists aren't close to each other, they're very far away from each other. Same with constellations. Constellations, the stars don't necessarily need to be close to each other. We're just seeing it in a 2-dimensional mode, whereas the problem is we don't have 3-dimensional eyes to be able to see stars. And actually we do, and that's going to be kind of talking about how we know, how far these things are. But anyway, those are constellations, and they're pretty cool. So one of my favorites is Orion the Hunter. It's because it's really one of the only ones I can see. I'm not really one of those star buffs who can go outside and look at all. But where do stars get their energy? And my answer is they produce their own energy. Do you guys remember we talked about 2 forms of hydrogen? This is a form of hydrogen called deuterium, and this is a form of hydrogen called tritium. How do I know they're hydrogen? Because you look at the plus molecules in there. Those plus molecules represent protons, and there is 1 proton in each of them. This happens to be the fat version of hydrogen, and this happens to be the regular version of hydrogen. But they're still hydrogen. And they combine together through this process called nuclear fusion to create what we call, what we know as helium, and a bucket load of energy and an extra neutron. We cool with that? When we covered this stuff, we talked about this thing. All right. Now, we can actually see these kinds of collisions happen, and scientists use this amazing tool called a particle accelerator. Here's a picture of it. It's in Switzerland, and this thing is like miles and miles and miles long. It's like the size of a small country. In fact, I think they have it in the scale of everything right here. Here's the LHC. And this is not the CERN one that's in Switzerland. I forgot where this thing was. I think it's somewhere in Europe. I think actually it might be in Switzerland as well. Anyway, look, it's the size of Halley's Comet. It's almost the size of Mount Everest. That's pretty darn big. And we get these things, these particles whipping, going around and around and around so fast that when they collide into each other, hopefully will create like new elements that we've never seen before. And that's pretty cool. All right, so we talked about particle accelerators. We're cool with that? Now, how do I classify a star? How do I know whether or not how do I know a star is different from another star? And here's how you do it. I have a hot cup of tea. How did I make that hot cup of tea? Well, I took the water, I put it in a pot, and I put that pot on a burner. You guys ever do that? You guys ever turn on like the coil burners? Do you guys have that at home, or do you guys have fire? Yeah, you have the coil ones? I have the coil ones because I'm poor. Anyway, Which not to say that like people have the coil ones are poor. It's just I think the fire one is more expensive. Anyway, you ever turn on the coil burner, and what happens is as it gets hot, it like starts to kind of have this like dull orange. Right. And then if you leave it on super hot, what it will end up doing is it will end up turning like a bright red, almost like a glowing red. And then if it gets even hotter and hotter and hotter, what's going to happen is after it turns this bright red, it will actually turn back to a bright orange. And then it gets extremely hot. Like if you could like get this thing hotter than is safe for your kitchen, you could turn this thing yellow, white, or even blue. That's like super hot. So one way that we classify stars is by their temperature, and we can figure out their temperature by looking at what color they are. Like we're talking about a blue star, we're talking about a super hot star. All right? And the classification system says, I think that there's this, what do they call it? Their mnemonic device that says O, B, A, fine, good kid, man. Oh, be a good, fine, good kid, man. And actually, to be honest with you, this classification system is very important for you to remember if you're going to be a cosmologist or an astronomer. But it's not necessarily that important if I mean, it's not as important as PEMDAS. But oh, be a good, fine, good kid, man. What it's saying is the classifications are O class, B class, A class, F class, G class, K class, and then M class. Doesn't make sense. I have no idea why they named it like that. But anyway, that's what they did. All right. So the first one I'm going to talk about is the O class, and it's the blue star. This guy burns over 30,000 Kelvin. Let me show you what a blue star would be. I think that I've seen one right. Actually, I didn't see one in this thing. This scale of everything doesn't have one. All right. The next one, O, B, a fine, good kid, right? So B is the B class, and we're talking about the blue whites. Those are the not so blue kind of whitish thing. It's not as hot. It's still crazy hot. It's like 10,000 to 30,000 Kelvin, but it's not that hot. And that would be Rigel. Rigel, he's right over here. There we go. Rigel is a class B blue/whitish star. Cool? All right, the next class is the class K class. Is Kelvin like Fahrenheit or Celsius? I love that question, Nolan. All right, so you guys, let's talk about that one real quick. And I know I'm going really quickly through all of this stuff, but remember, there's a lot of material I got to cover. So if I blow you away, just stop me and let me know. But anyway, we're talking, I didn't tell you about Kelvin. Have you ever heard about Kelvin before? Yes? No? Okay, all right, check this out. Have you heard about the difference between Fahrenheit and Celsius? Yes. Okay. You know that part of the world measures things in Fahrenheit. You and I probably measure our temperatures in Fahrenheit. Whereas the rest of the world, besides Burma and the United States, measures things in Celsius. It's probably a much more understandable way of measuring things in Celsius. You guys get that? But I mean, there's just these different ways of measuring things. And yeah, I mean, you understand, like there's just these different ways. And they even have this way of converting it, which actually all of you folks should learn how to do, because I know that that's always on some kind of standardized test. So Fahrenheit, Celsius. Now, what is Kelvin? Okay, let me tell you a little bit about Celsius. How did we get 0 on the Celsius scale? What is 0 degrees Celsius? What's like the most common thing? Freezing. Good. Very good. The way they made Celsius, they said, okay, well, one of the most common important elements like to humans is water. So let's make the 0 degrees Celsius to be the smallest, to be really, really cold, or to be like 0. And that's the freezing point of water. Let's make the boiling point of water to be 100. And then let's divide it into 100 different pieces, and that's how we're going to build this thing called Celsius. Are we cool with that? Now there was this dude, his name was Lord Kelvin. I don't know what his first name was. I think it was Reinhold. Anyway, Raymond or something. It starts with an R, I'm pretty sure. Anyway, Lord Kelvin came along and says, you know, I love Celsius. It's a very good way of measuring things, but the problem is negative numbers really freak me out. So what I'm going to do is I'm going to say 0 is no longer the lowest degrees you can get to. Because you can have negative 5 degrees Celsius, right? You can have negative 10 degrees Celsius. So he turned the volume, or he turned the temperature down all the way until he figured out that there's a point where you cannot get any colder than a certain point. And that point where you can't get any lower, he called, that's my new 0. And it ends up being about negative 363 or 68 or something like that Kelvin, or degrees Celsius. So really, he just started the 0 at a different spot because he didn't want any negative measurements in temperature. So when you're measuring things in Kelvin, 0 degrees Kelvin is actually a spot that you can never get to. It's a theoretical, nobody can ever get to that spot. It's like going the speed of light. You can't get there. You could get really close, but you can't get there. It's impossible to get there. But we call that absolute freezing temperature, and absolute freezing temperature is actually, that's actually 0 degrees Kelvin. Which is, if you had the same thermometer, it would measure negative 328, I think it is. I think it's negative 300 something degrees Celsius. But anyway, that's the difference between Kelvin and Celsius. So really, if you want to figure out like, oh, okay, what is a 10,000 degrees Kelvin measured in Celsius? Well, my answer to that would be, it's very easy. All you do is you subtract 348 from this number, and that will be your degrees in Celsius. But it's still very big. We're talking like hot stars here. All right. Now the class F stars, these guys are pretty cool. Okay, let me kind of scroll down on this page right here. All right. Oh wait, I skipped the white stars. All right, so we got class A stars, which is, I think a good star for that guy would be Sirius. Or Cyrus, if you want. Where's Sirius? Oh, he's at 9.6, so he's a little smaller. There we go, Sirius A. Sirius A is a white star. It's an A, class A star. It is like the dog from the radio, and actually that's kind of what they named the dog after. And I believe that they named it after the dog because it's found in the dog constellation. But Sirius A is a class A star. It's a white star. It's not as hot. It's only 7,500 to 10,000 Kelvin. Not as hot. All right. Now we're getting into a class F star, and a good one for that would be Polaris. I think Polaris is a little bit smaller. He's like right around, where is he? Oh, I think Alpha Centauri is also a class F star, which is the yellowish white. It's still hotter than our sun, but it's not as hot as like, everything. It's not as hot as the other ones. All right, now we get into my personal favorite, which is a class G star. And this is the yellow star. My best example for a yellow star is the one we're most familiar with, our sun. I'm a very big fan of our sun, because if we didn't have our sun, we'd all be dead. And these guys burn between 5,500 and 6,000 degrees Kelvin. Yes, question. Oh, what do these class letters mean? No, we're just developing like a class, like we're developing a system in order to kind of rate these things. And really, the system that we use is these letters. and we use the color to kind of help us identify the letters. But the thing is, memorizing which, the different classes and the order of the classes and what is a class F star and all that kind of stuff, that's not going to help you. I'm just trying to explain it to you to make sure that you guys know. All right, here's a really good one. I like this guy. This guy is Arcturus. He is a class K star, and that is straight up orange. So we have a yellow sun. Arcturus is an orange sun. Here we go. Here's Arcturus. He's a big guy.